In this video we're going to look at resultants of non-parallel forces. So when working with forces which are not parallel or perpendicular, we have to resolve the forces into two perpendicular directions. So generally this will be vertically and horizontally. It may also be parallel to a plane and perpendicular to a plane. So we're going to look at our first example here. Okay, so this first example says calculate the magnitude and direction of the resultant of the forces shown below. So the first thing I'm going to do is I'm going to resolve to the right. So that means I'm taking anything going to the right as positive, and I'm going to see what I have. So I've got a 10 going to the right here. I've got a 11, but it's not all 11. It is 11 cos 40. I'm going against that is this 5 newtons, and it's going to be 5. So minus 5 cos 25. And then what we have to do here is work out this wee angle in here. So this wee bit in here. So if we add those up, you've got 40 plus 90. 40 plus 90 is 130. Take 130 away from 180, you will get 50 degrees. So a wee bit of working out to get that one. So that also needs to be taken away. So minus 6 cos 50. So if you work all of that out and tidy it up, I've got 10.0382, and you can see I've gone to 4 decimal places. What I'm also going to have to do, I'm going to guess that overall this thing's going downwards. We'll see, but I'm going to take downwards as positive. So what we've got going downwards, I have got 11 sine 40 this time. It's sine because the angle is not here, so that's why you have to use sine. And also going downwards, I've got 6 sine 50. Again, it's sine because I don't have this angle. So that's why we're using sine 50. And then going against that, so which is going upwards then, is 5, and it will be sine of 25. So when you work that out, what you get, the 4 decimal places, is 9.5538. So now what we've seen is that this system of 1, 2, 3, 4, 4 forces has now been reduced to just a horizontal force and a vertical force. So what we want to do is just redraw as a triangle. So we've reduced 4 forces down to 2 forces. Then what we want to do is reduce it down again to a single force. So what in this triangle, I like to start with a horizontal. I had 10.0382 going horizontally, then going vertically, and it was vertically downwards. I had 9.5538. And that's what we had, and that's my angle, and I'll call this R. This is my overall resultant. So to do it, the rest of this then is just Pythagoras theorem and trigonometry. So R is equal to the square root of that 10.0382 squared plus 9.5538 squared. And when you do that on your calculator, don't be a hero, you'll get 13.86 newtons, and I've gone to 2 decimal places. Likewise, you can use your tan. Tan theta, remember, is opposite over adjacent, so tan theta is equal to 9.5538 divided by 10.0382. Do tan to the minus 1 of that thing, and you will get 43.58 degrees, and that again I've gone to 2 decimal places. Our last example for this video says forces of magnitude 8 newtons, 10 newtons and 11 newtons act in the direction of A to B, B to C and A to C respectively on the triangle ABC, which is shown below. Find the magnitude and the resultant of these forces. So 8 newtons, first of all, acts in the direction of A to B. So from A to B, you've got 8 newtons going along here. The next one is 10 newtons, acts from B to C. So from B to C, that's going to be 10 newtons. And the last one, it's 11 newtons, acting in the direction of A to C. So there is your 11 newtons going this way, and that's what we've got. Okay, we are going to resolve horizontally and we're going to resolve vertically just as we did in the last one. So resolving horizontally to the right, what you have is a nice 8 newtons, which is completely horizontal. You also have got 11 newtons, and it's 11 cos 35. Going against that is minus 10 cos 50. And again, multiply that out, tidy up, and you will have 10.5828 newtons. 10.5828 newtons. What we also want to do is resolve, and I'm going to resolve vertically down. And we've only two forces going downwards. You've got the 11 sine 35 in this case, plus 10 sine 50 in this case. And if you do that, what you're going to get is 13.9698, and that's the 4 decimal places. Okay, last thing we've got to do here then is just to do your horizontal line. Use your imagination, that's a horizontal line. That was 10.5828 going horizontally. Then going vertically down, it was 13.9698. These are just sketches, so it doesn't matter that mine's a mess. Preferably it wouldn't be, but it is. And there's your resultant, and there is your angle theta. So to get your r again, it is just Pythagoras, so it's the square root of whatever that was, 10.5828 squared plus 13.9698 squared. And when I put that into my calculator, I got 17.53 newtons, and that's to 2 decimal places. Your tan theta is going to be equal to, tan is equal to your opposite over adjacent, remember, so 13.9698 divided by 10.5828, which means your theta is equal to, and I've got doing that in my calculator, 52.85 degrees, and again that was to 2 decimal places. So there we have it, to whatever number of forces it is, could be 100 forces acting at all different angles. Just resolve horizontally and find an overall resultant, horizontal component I should say. Resolve vertically and find an overall vertical component, and then put those into a right angled triangle, and then it's just a case of Pythagoras to find your resultant on the diagonal, and also using trig, and it's going to be tan is equal to opposite over adjacent to find your angle.